Today's notes are from chapter 6 in the textbook on earthquakes. And this part we're going to first talk about is what is causing earthquakes, including stresses in the crust. This is some of the vocabulary you should know. You should write it down and add it to your notes. So please follow along now. Stress. Do you guys remember from yesterday? Anyone read what stress is? Do you have that in your notes? Okay, so a stress is going to be a force in the crust, and we'll get to that. You're actually jumping ahead of us a little bit. Stresses are forces in the crust, in the Earth's crust, the surface of the Earth. And we can divide those into three major types of forces. The forces in the crust either push together, they pull apart, or they go side to side. And if you're looking in the textbook, this is page 162 and 163, and these forces are part of what's going to cause earthquakes. Now, we're kind of starting on chapter 6 because I want to talk about earthquakes first, and then after we talk about them a little bit, then we'll go back about what's causing the forces. But the three types of forces, and I think drawing pictures is usually helpful, pushing towards each other is a force called compression, which makes sense. Sometimes in science, the words are exactly like we use them in everyday life. Compression is a force that pushes together. And so what type of landforms might be caused by forces of the Earth pushing together? Absolutely. You might get mountains. You can also get, this one here just kind of looks like a hill. It also sometimes makes folding. So if you could look at the layers of the rock, you get kind of, you can see that the layers that used to be flat are kind of now folded. And extreme cases, you can actually see the layers kind of folded like this. And here in Colorado, if you're driving along the highway, if you go through a road cut where they've literally cut through the hills to put the road through, you can sometimes see the different layers. So compression is the force that's pushing together. Then we have forces that's pulling apart. So again, pretty straightforward. A word we're familiar with, tension. Tension is a force that is pulling in opposite directions. And that, as you can see this here, it's kind of making a valley. Sometimes it makes something called a rift. It can actually pull hard enough that you get cracks or tears in the earth. So tension, a force pulling apart. Again, pretty straightforward. Pulls on the crust, stretching the rock so it becomes thinner in the middle. That sounds exactly right. And then finally, the third type of force is called shearing. Now this one's a little more confusing, but shearing like scissors, shearing is a side-by-side force where one part is going this way, the other part's going this way, kind of opposite directions. We'll use a color we can see here. And what's going to happen here is you're sometimes going to get a sort of tearing in the crust. And if you put your hands side by side and move them back and forth like one against the other, that's kind of what's happening. Sometimes the two are moving opposite directions, sometimes one's still and one's moving. And this is that little video clip we watched yesterday. We saw the San Andreas Fault, and you could see that large crack and hills in the Earth's surface. Just from an airplane, you can see that shearing is happening there. And we'll continue talking about these forces and also plate boundaries, which is a little bit bigger version of the same thing. So stress, forces in the Earth's crust, and the three types of stress. So three types of stress: compression, tension, and shearing. Make sense? Okay. And with these, usually with these, I also have pictures on the quiz because it makes it a little bit more straightforward. Everybody ready to go to the next page? All right. So next we have a fault. A fault, let's go ahead and cover this up so we can do this better here. An earthquake fault is a crack in the Earth's surface Earth's surface. This is usually where earthquakes are going to occur, is at faults. And generally, you're going to have movement at the different faults, as you'll see in these pictures. So it's a crack in the Earth's surface. It's usually caused by some sort of stress or tension. And the types of faults, to me, are really kind of less important than just kind of knowing what's going on. I find these sometimes to be a little bit confusing, both in what they are, both in their names and what's happening. If you want to follow along in the textbook, this is on page 164 and 165. First, you have a normal fault, which seems like kind of a funny name. But a normal fault, you can see here, in a normal fault, the forces are moving away from each other. So you're having, what type of forces pulling away from each other? Type of force? Tension. So you've got tension, and because there's actually a crack in the Earth's surface there, what happens is this wall, this area kind of falls down compared to this area. So, and this says in the textbook, in a normal fault, the hanging wall slips down relative to the footwall. Anyways, the point I want you to know is that this is tension, and this part slides down. In a reverse fault, or in a strike-slip fault, we've got side-by-side movement. You're jumping over this way. First, we got to do strike-slip. Has an annoying name, but what's happening here? What's our force? Shearing. They're moving side by side, and they just move right next to each other. Again, this is like the San Andreas fault. They just, rocks on either side, slip past each other. San Andreas fault. And so this is basically shearing. And then finally, the reverse fault. And the main difference here between the normal fault and the reverse fault is that instead of moving apart, in the reverse fault, they're being pushed together. So because they're being pushed together, one of the walls gets pushed up over the other one. So you can remember it's reversed because this is going to be odd looking, right? The hanging wall, and basically it's which one's moving. This one, the one that's moving, falls down. That's normal. That makes sense. This one, you've got compression. It's pushing together, and the hanging wall pushes up over it. So those are the three types of faults. Knowing the three stresses is more important than the three faults. But to kind of show you a little bit better example, let me grab my little earthquake demonstrating things. All right, the next set of words that you need to know are the types of seismic waves. These are the earthquake waves. So seismic means shaking. So these are the shaking waves. Seismic waves. Seismic means shaking. So a seismograph is a graph of the shaking. A seismometer measures the shaking, although we usually call the measurer a seismograph also. So these are earthquake waves. And it turns out we're able to learn a lot from the actual shaking waves. There's three types of waves. There's P waves, S waves, and surface waves. And you can remember these because they have very nice, easy ways to remember them. P stands for primary waves. They arrive first. Primary waves arrive first. They're the fastest of the earthquake waves. You can also remember the motion they make is also called a push-pull motion, like this. Then we have the S waves. S for secondary waves or side-to-side motion. It's going to look more like this. It will either go up and down, the Earth will go up and down, or the Earth will go kind of side by side, if you can imagine that. They arrive second. They're the second fastest. And then you have the surface waves, which are called the L waves, obviously. They're actually called the love waves because they're named after some dude. But you know what? We just call them the surface waves. And the surface waves are a combination of the P wave and S wave motion. So at the same time it's pushing and pulling, it's also going up and down. And as you can imagine, these are the most destructive of earthquake waves because you've got motion happening in two different directions at the same time. And I'll take a moment right here to demonstrate to you what they look like, and then we'll talk about the epicenter. Actually, let's do the epicenter first, because then I can just give you the earthquake demonstrators. So the last two words we're going to do are epicenter and focus. So let's quickly draw a cross-section of the Earth. Why don't you guys set down the earthquake boxes for a minute? Thank you. Maybe you could grab those for a minute. We'll give you back the earthquake boxes in a moment. So if you draw a cross-section, here's the surface of the Earth. Here is a fault, and this fault is going to go, let's make the fault go like this. So you can imagine the fault goes down deep into the Earth, and so there's a cross-section here. Let's put a little city over here. We'll put some buildings here. Those are buildings. And then we'll put some little houses out here on the outskirts of town. Yeah, I got some little suburbs here. Whoops. With, you know, some little trees. Okay. And then out here we'll have just some other trees out here, a little forest. Okay? So the earthquakes generally happen somewhere along the fault. Let me get this fixed up here. The fault is, of course, the weak spot, the crack in the Earth's surface. Now, these people in this city might think, hey, you know, we're pretty safe. We know there's a fault, but it's outside town. It's way over here, a couple kilometers, a couple miles outside of town, so we're not so worried that we're going to have any earthquake damage. The problem is the fault might not be exactly straight, and what if when the earthquake happens, it happens under the ground? So remember I said if your hands are rubbing side by side and they're moving in opposite directions, at some point the weak spot breaks and they slip. So they slip, that's an earthquake, and the point where the earthquake breaks, the point where the fault breaks, is called the focus. That's where the earthquake, let's move the fault up here. This is the focus. So the definition of the focus is the point along the fault where the earthquake starts. And I'm just going to put EQ for earthquake. And oftentimes it's deep underground. And when you hear people talking about an earthquake, reporting about it, they'll say the fault ruptured, you know, a mile beneath the surface or something like that. And then we have what's called the epicenter. You know what epi means? Epi means on top of, like your epidermis, on top of the dermis. An EpiPen goes on top. So epi means on top of the center. So where's the epicenter? The epicenter is where the earthquake appears to come from on the surface. So epicenter is the location on the surface, and it's directly above the focus. And this is where the earthquake appears to come from. If you look at this, where's the epicenter of this earthquake going to be? Not everywhere. It's going to be right here, directly above. Everywhere. That's not everywhere. So the epicenter is going to be right here, very close to the city, even though the fault seems to be outside of the city. Okay? Is it going to take out the forest? Probably not. The trees, you know, they're flexible enough. They might fall down. Probably not. Little animals, they'll just run away, no big deal. But if the buildings are going to shake back and forth or up and down. And so we could have problems with the buildings. So that's it for the words. What we're going to do next, I'm going to give you some different things so that you can practice making the waves, seeing what those waves look like, and then you can practice watching this flip lesson at home.